Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at Grade 10 Mathematics Algebra Part 1, Algebraic Expressions. So let's quickly look at the work schedule. And the work schedule is as follows. KZN Department of Education Mathematics Annual Teaching Plan, Grade 10 2021. And it reads as follows. So if you can see here, it says that we want to understand that a real number can be rational or irrational. Know the difference as far as the decimal expansion of the numbers are concerned, and establish between which two integers a given single surd lies. And I also want to look at rounding of decimals to an appropriate degree of accuracy. Now, the first thing that we have to understand is our definition of rational and irrational numbers. Remember that a rational number is any number that can be expressed in the form a over b, where a and b are both integers, and b is not equal to 0. Remember, an irrational number is any number that has a non-recurring or non-terminating decimal value. So if we look very carefully at this, we normally have the complex number system. So complex numbers can be classified into the following: real numbers and non-real numbers. And remember now, our real number system can be classified into rational numbers and irrational numbers. And our rational numbers now will be as follows. Remember, our rational numbers can be natural numbers, whole numbers, and integers. So if we move up this tree, remember that a non-real number, an example of a non-real number, is the square root of a negative number. We normally say it's going to be the even root of a negative number, but you would mainly see it as the square root of a negative number. Remember, that's non-real. Now, real can be, any real number can be either rational or irrational. And our natural, whole numbers and integer numbers, remember now, are all rational and real. So we can follow this tree diagram up as follows. Also, a very important definition for you to know is that a number is classified as undefined if we are going to have division by 0. So any division by 0 is undefined. And remember, non-real is the even root of a negative number. So let's go and look at some questions now pertaining to the theory that we just went over. So if we look at some past examination questions, let's look at this. So if we look here at the November 2018 paper and we work our way up here. Okay, so there's no questions there. Let's go here. Alright, so the November 2017 paper says question 1.1, given q is the square root of b squared minus 4ac. Determine the value of q if a is equal to 2, b is equal to minus 1, and c is equal to minus 4. Leave your answer in the simplest surd form. State whether q is rational or irrational, and determine between which two consecutive integers does q lie. So let's have a look at this question here. Looking at this now. Okay, so we just grab this question here and let's go and answer it. Okay, so what are we going to do here? Determine the value of q. If a is equal to 2, b is equal to minus 1, and c is equal to minus 4. Leave your answer in the simplest surd form. So the surd form will be, we're going to leave our answer in the root form. Okay, so let's substitute. So for 1.1.1, we say q is equal to the square root of b squared minus 4ac, square root of b squared, so that's going to be minus 1 squared minus 1 squared minus 4, and the value of a is 2, and the value of c is minus 4. So let's put that all underneath the square root sign, and let's put that in our calculator. So in our calculator now we'll have, let's use brackets whenever we are substituting, minus 1 squared minus 4. And here we got 2. There is minus 4 minus 4 equals to square root of 33. So our answer, we're leaving it in the third form. See, the third form is the root form, square root of 33. Okay, so the first question now is done. Let's look at 1.1.2. State whether Q is rational or irrational. As per our definition, remember I told you that any number that has a non-recurring or non-terminating decimal, or any number that's in the third form, will be irrational. So therefore 1.1.2, answer will be irrational. So for 1.1.2, answer will be as follows. Irrational. Between which two consecutive integers does Q lie? So we now need to look for those integers. So remember now the square root of 33. Now what is an integer? An integer is a positive or negative whole number including 0. So therefore we can have a number set which looks like this. So minus 2, minus 1, 0, 1, 2, 3 are all examples of integers. Remember, positive or negative whole numbers including 0. So therefore if you have the square root of 33 now, right, it's going to be as follows. We need to look at two perfect squares on either side of the square root of 33. So the square root of 33. So if you look to the left, you can see that we'll probably have down the side here square root of 25, and on this side square root of 36. So therefore the square root of 25 is 5 and the square root of 36 is 6. So I think it's important for us to know our square roots and cube roots and our squares and cubes, just as it's important for us to know our bonds and tables. If you are stuck, now you can just double check using a calculator the square root of 33. Press the decimal, 5.7. And you can clearly see that 5.7 will lie between 5 and 6. So therefore the answer will be between 5 and 6. Let's go look at another question which pertains to this first section here, right? So that was the 2017 paper. So let's just go up here. See, this is the 2015 paper now. All right, so there we go. Consider the following numbers: square root of 27, the cube root of minus 27, and the square root of minus 27. Which one of these numbers is irrational and which one is non-real? So let's look at this question here now. So we can clearly see the solution, right? Have you figured it out as yet? All right, let's have a look. Okay, so there we go. So irrational number, remember, is going to be a non-recurring or non-terminating decimal. So that means it's not a perfect square or not a perfect cube. And you can see here that square root of 27 is not a perfect square, right? Root here, so we are going to get an irrational value here. Okay, the cube root of minus 27 is going to equals to minus 3. And you can see that this number here is the square root of minus 27. So here we have the square root of a negative number, so this is going to be non-real. So our solutions will be as follows. 1.3.1. Irrational will be the square root of 27. The reason for that is if you put the square root of 27 in your calculator, you'll be able to see square root of 27 equals to non-recurring and non-terminating decimal there. And if we put the cube root, of minus 27, we should get minus 3. And also now remember, if you put the square root of minus 27, calculator should return an error. Square root of minus 27, we should get an error. Error means now that this thing is non-real. Okay, so 1.3.2 square root of minus 27. All right, Let's go look at another question if we can find one. Let's see. And we got the exemplar 2012 here. Right. So there we got another question here. (1.3) and 1.4. Okay, so let's have a look at that. So it says here, determine without the use of a calculator between which two consecutive integers the square root of 51 lies. Now, this is similar to a previous example that we did. We need to look at now, because it's a square root of 51, we need to look at true perfect squares on either side of square root of 51. So we have square root of 51. Let's look here to the left and then to the right. Okay, so if you go backwards here, 51, 50, 49. Remember 7 squared is 49, right? So the square root of 49 is going to be equal to 7. Then if you go up this way now, see, after 7, what comes after 7? 8, right? So 8 squared is about 64. So the square root of 64 is equal to 8. So what can we conclude? Therefore, it will be between 7 and 8. You can double check using your calculator. The square root of 51 equals to 7.14. 7.14 will lie between 7 and 8. Last question that we'll look at in today's video. Prove that 0,245 recurring decimal this is now. We must prove that it is rational. Now the shortcut for this one over here is that 0,245 recurring is, you see, you put this decimal part 245 in your numerator, and for each recurring decimal you put a 9 in your denominator. Okay, and let's go see whether that works out here. So that will be 245 all over 999, and let's see, 0,245, 245, 245. Okay, so that's recurring. Recurring means that these digits are going to be repeating. 240, 245, 245, 245. Now let's see now, how do we do it algebraically to actually prove that 0,245 recurring? 2 recurring, 4 recurring, 5 recurring is a rational number. Now remember, a rational number is any number that can be expressed as a fraction, right? So a over b, where a and b are both integers, and obviously b can't equal to 0 because that will be undefined. So 1.4. So what we do first is that we're going to let x equals 2. We're going to expand that number 0,245. So we're going to write 0,245, 245, 245, and we're going to call that equation 1. Now for each recurring decimal that you have, you're going to multiply by, if you got 1 recurring decimal, you multiply by 10. If you got 2 recurring decimals, you multiply by 100. And if you got 3 recurring decimals, you multiply by 1000. So because we got 3 recurring decimals, we're going to multiply by 1000. So we're going to say equation 1 times 1000. So therefore we'll get now 1000 x equals 2. So this comma now will move 1, 2, 3 places to the right. You get 245.245, 245, 245, 245, and that's now equation 2. The whole point of this now is to make these recurring parts here the same. That's why you multiply, because when you subtract now, equation 2 minus equation 1, these recurring parts will cancel off. So that's why now we're going to say equation 2 minus equation 1, and you get 1000x minus x is 999x equals to 245 minus 0 is 245, and the recurring parts cancel out. So therefore now solving for x leaves us with x equals to 245 over 999, and I already showed you that 245 over 999 is equal to 0,2 recurring, 4 recurring, and 5 recurring. Learners, if you haven't subscribed already, don't forget to subscribe to JL Maths. You can watch all my videos in order of the work schedule on jlmaths.com, and check out all the videos as well on my Facebook page, Justin Lazarus Mathematics. And I'll catch you in the next video.